So hey guys, welcome back to the channel, and today we are going to do the three derivations of equations of motions. So let us begin by doing the derivations. So first of all, as you know that we have to first draw a graph. So on x-axis it is time, which SI unit is second, and on y-axis it is velocity, which SI unit is meter per second. So OD is time, OA and BD are equal, so it is UU is initial velocity, CD is V, that is final velocity, and BC equals to DC minus BD, and BD is equal to AO as I told you earlier. So DC minus AO will be equal to BC. So yeah, BC is V minus U. So let us derive the first equation of motion. So we know that acceleration is change in velocity upon time. So change in velocity will be what? BC, that's V minus U upon OD. No, actually AB, but AB and OD are equal. So that's time. So now we can take the T to the LHS, and AT is equal to V minus U. And here we can take that minus U onto the LHS, and we can write it as V equals to U plus AT. And hence we have derived the first equation of motion. Now let us start deriving the second equation of motion. So the area of graph gives us the distance. How much the area that the graph covers gives us the distance. So we need to find the area of quadrilateral ODCA, which is nothing but just the sum of area of rectangle AODB plus area of triangle ABC. So as you know that area of rectangle is L into B and area of triangle is half into base into height. So here length will be OD and breadth will be OA, and here half into base into height. Base is AB and height is BC. So as you know that OD is time and OA is U, that's initial velocity. So yeah, AB is equal to OD because it's parallel, and BC we know that it's V minus U. So let us put the value, that's UT plus half into T into V minus U. Now as we know that A equals to V minus U upon T, so AT equals to V minus U. So we can substitute V minus U by AT. So yeah, we can write that AT instead of V minus U. So here is our second equation of motion, that is S equals to UT plus half AT square. So the second equation of motion has been derived. Now let us start with the third equation of motion. We have to derive that now. Okay, so this rule applies in this also. As I have told you, the area of graph gives us the distance traveled by the object. So the distance traveled will be S, and we need to find the area of trapezium ODCA. So area of trapezium, the formula is half A plus B into H. A and B are parallel sides, and H is the distance between both the sides. So we need to write half. Now instead of A, that's OA, so that's U plus B. B is V. So we need to write U plus V, and the height is T as OD. So we know that A equals to V minus U by T. So when T goes onto the LHS, we can find out the value of T. That's V minus U by A. So we can substitute V minus U by A instead of T. And here if we write U plus V or V plus U, it's the same thing. So half into, now it has become V square minus U square because it was V plus U and V minus U. So yes, S equals to V square minus U square upon 2A. Now 2A will go to LHS, and 2AS equals to V square minus U square. So that's the third equation of motion, and we have derived. Thank you for watching the video. I hope you would like the video and your concepts would be clear. Make sure you subscribe to my channel, hit the like button. If you got any benefit, comment down below on which more topics should I make videos. Thank you for watching. Bye bye.